Welcome back to the seventh and final section of Chapter 2. In this section, we're going to be looking at inverses and their derivatives. Inverses is a topic that you've seen for the past few years, and we've used them a little bit here and there. But today we're going to review that quickly and then see what we can do with derivatives of inverses. So, first question is inverses. What are inverses? Inverses just switch the input and the output of a function. For example, the conversion function to go from Celsius to Fahrenheit. The inverse is the function to go from Fahrenheit to Celsius. So it switches the input and the output. So one of the things we're going to look at is how do we see an inverse with graphing. To graph, when you switch the input and the output, it switches the x and the y axes, and effectively, it just reflects across the line y equals x. So if we wanted to sketch a graph of the inverse of this function, we're going to have to reflect it across the line y equals x, which gives us a graph, looks kind of like that. So the asymptote over here becomes an asymptote right over here, and then it goes up. Anywhere the graph would hit the y equals x line, the inverse and the graph will intersect. Because if y equals x, when you switch it, y still equals x. It's the same point. So if we had a different graph that went, let's say like that, the inverse of that, we're going to hit this point, we're going to hit this point, and it's going to look kind of like that. So anyway, you're reflecting across the line y equals x. A little bit of practice on that does help, and so we'll have some of that. Another thing we'll be doing with inverses is finding an inverse. If we have an equation, find the inverse of it. Now, there's a couple types of equations that we can have and do this for, but what we do is we switch x and y. Now, in the type that we're going to look at here, which would be f of x equals 5x cubed plus 9, the x and the y really have no meaning behind them. It's just the input and the output. And so we're going to switch x and y, like quite literally. The first step, we're going to have y equals 5x cubed plus 9. Our very first step is we're going to switch x and y. X equals 5y cubed plus 9. And so in this case, it makes sense to do that because x and y don't have meaning. If we were going back to talk about that Celsius and Fahrenheit function, we use C and F. If we switch them, now C stands for Fahrenheit and F stands for Celsius. That doesn't make sense. So in a situation like that, just solve for the other variable. C equals something. The inverse is going to be F equals something. You just solve for it. In this case, we switch x and y, and then we solve for y. So we're going to have to subtract 9. So x minus 9 equals 5y cubed. And then divide by 5. X minus 9 over 5 equals y cubed. And then take the cube root. Cube root, there we go, of x minus 9 over 5 equals y. And then we started out in function notation. We're going to put it back into function notation. The notation for an inverse of f of x is f negative 1 of x. It's very similar to the Lagrange derivative notation where we have the primes. It's just a negative 1. And it equals the cube root of x minus 9 over 5. And so that's how to find an inverse. Sometimes we can't find the inverse. If we cannot isolate this x, or what becomes the y, to solve for it, we can't actually find the inverse, but we can still find values of the inverse. So an example of one would be something like f of x equals x to the fifth plus 3x cubed plus 2x plus 1. We're not going to be able to find the inverse of that. If we switch the x and the y's, we'd have x equals y to the fifth plus 3y cubed plus 2y plus 1. And we're not going to be able to get y equals from there. It's just not going to happen. But we can find the inverse of 1. So if we had the inverse and we plugged in 1, what would we get? Remember that the inverse it switches the input and the output. So the input of the inverse is going to be the output of the function. So f of 1 equals a number means that if we plug a number into our function, we're going to get 1. So we're going to have 1 equals x to the fifth plus 3x cubed plus 2x plus 1. And now we need to solve for x. And so we'll subtract. So we get 0 equals x to the fifth plus 3x cubed plus 2x. And we're going to have to factor. This may include factoring like a quadratic. It may include factoring by grouping. In this one, we're going to factor out an x first, because the very first step in factoring is factor out what they have in common. So we have 0 equals x. Then we're left with x to the fourth plus 3x squared plus 2, which can factor. That one will factor like a quadratic. So we have x squared and x to the fourth. The x to the fourth is exactly 2 times x squared. So we can factor it like a quadratic, but instead of x and x, we'll have x squared and x squared. Then two things that multiply together give us 2, but add to give us 3, plus 2, and plus 1. Now we need to look to see what makes this 0. Well, either x could equal 0, in which case x equals 0, or x squared plus 2 could equal 0, or x squared plus 1 could equal 0. But in both of these guys, x squared is positive, or 0, greater than or equal to 0. When you add 2 or 1, it's going to be positive. It will not equal 0. So these are not going to give us a 0. But that does. And so the inverse, if we plugged in 1, we get 0. That's how to find it. Now the question you might ask is, well, what if these did give us roots? You should only get one solution, because in what we're working with here, the inverse is generally going to be a function, or at least it will be where we're looking for it. If you had multiple answers, we'd get into whole other messes that is not really what we're dealing with here. So we found the inverse at 1. It equals 0. Next, we can actually find the derivative of an inverse. Now there's two ways this could happen. If we can find an inverse, you just then would literally find the derivative of that inverse. That is not fun. It is not entertaining. Well, I mean, it's not unfun. It's just finding a derivative. There's nothing there. We're not even going to look at that. We're going to look at finding the derivative of an inverse when you can't find the inverse itself, because that's fun. So to do this, we're going to look at the definition of inverse. And we've seen this before. F and G are inverses if and only if f of g of x equals x and g of f of x equals x. So those two things have to happen, and if that is true, they're inverses. So, and here we're using f of x and g of x instead of f of x and f to the negative 1 of x, because if we're taking a derivative of f to the negative 1, what would that even look like? F to the negative 1 prime, it gets awkward. So we're going to say g of x is the inverse of f of x. So we can find the derivative using this, and we're going to use this formula. The other one is going to work out exactly the same. It's no different, but we're going to use this one. So if we start out with f of g of x equals x, we can find the derivative of both sides. For the left side here, we're going to use the chain rule. That's going to be f prime of g of x times g prime of x. And then that equals the derivative of x is 1. So if we have f of x, we want to find the derivative of g of x. We have the derivative of g of x right here. We just need to divide. So g prime of x equals 1 over f prime of g of x. That's the derivative of the inverse. Now, if we wanted to find this as a function, we would actually have to know what g of x equals. And so we'd have to be able to find the inverse. We might not be able to find this as a function, but we can find the derivative of the inverse at a point. The derivative of the inverse is at a point. We're just going to have to figure out what g of that point is and what the derivative is, and then plug it in. So if we look at a question, this would be the same one that we saw on the last slide. F of x equals x to the fifth plus 3x cubed plus 2x plus 1. We need to find g prime of 1. So to do that, we need to know a couple things. We need to know g of 1, which is what we just did on the last slide, if you remember. G of 1 in this case equals 0, but we just plug that in for the y value of f of x, and then we solve for x. The other thing we need to find is we need to find f prime of x. So in our case, that's going to be 5x to the fourth plus 9x squared plus 2. And then we're going to plug in that number. We're going to plug it into x. So we're going to have f prime of 0 in this case, which is going to be 5 times 0 to the fourth is 0, plus 9 times 0 squared is 0, plus 2. So f prime of 0 equals 2. That is the denominator here, right? The 0 was that guy. F prime of 0 is now the whole denominator. So g prime of 1 equals 1 over 2. That last step, going 1 over what we found, is what people forget the most. A lot of times, people end up giving me this answer right here. You're almost there. 1 over that answer. And we found the derivative of the inverse at that point without ever finding the inverse beforehand. How cool is that? So this is what we're working on today. It's the last section of the chapter. So keep working problems, keep asking questions, and as always, happy mathing.